you. So we're going to review the first three sections in chapter 13. The first one starts with circles and parabolas. We'll do a little bit of each. Do probably really a little bit of parabolas. The one thing to make sure you're really comfortable with is the general form of the equation of a circle. That's this one right here. If you have an equation in this form, then it's a circle with a center at H and K. And the radius, you got to be careful, the radius equals R. So it's actually the square root of that right-hand side. Now you could take equations like the first one in example A, they ask you for the center and radius. You could make it look like this. What I prefer to do instead is just ask myself, well, what value makes the squared term equal to 0 here? What would I put in for x?
-3.
-3. And what value makes the squared term 0 there? Well, just 0, right? So there we go. And then, you know what? I copied down an r squared. There's got to be something other than an r squared there. So let me look back at the original problem. There we go. That should have been a 1 squared on the right-hand side. So actually not even a 1 squared, just a 1. So let's go back here and look. It never happened. The radius, you don't have to put the square root of 1. I'd much prefer to see you put a 1. And there's your answer. Center and radius. Now, sometimes they ask these problems in kind of a reverse order. Sometimes they'll give you H and K, and then your job is to plug those into this equation. Now I'm going to plug it in and simplify it all in one stroke, because x minus -0.7, that double negative becomes a positive. So it's going to be x plus 0.7 squared. And then likewise here with the y's, y minus -0.2 becomes y plus 0.2, still squared. And I'd probably be happiest if you simplified the right-hand side. What's the right-hand side simplified to? Can anyone tell me what you get when you square the square root of 13?
13.
Thank you, 13. Beautiful. And that's it. There's your equation. So hopefully a couple quick and easy points. Wait a minute.
That was easy.
There we go. Nice. This one's going to be a little bit harder. We're going to have to put this into this form in order to determine the center and radius. Like they might just ask you to put it in that standard form. That's all they do here. So let's practice that, and that'll help us with a parabola problem that comes after this. The first thing I would do is I would take and get the x's together like this. And let's anticipate something. I'm going to put a plus here. And the y's together here. And again, I'll put a little plus here. Equals -24 plus something plus something. So what we're going to have to do is complete the square on the left-hand side for the x's. And when we add in that number here, we'll also have to add a number over here. Likewise with the y's, when I complete the square here, I'll have to add a number over there as well. So how do you complete the square here? You take half of the middle number and you get 4. Is that it? That's all I need to do? Put a 4 in here?
You just square it now.
Yeah, you got to square it. So there's 2 steps. And when you square it, you get 16, which I'll put here. And I'll also put that over there. You got to keep it even on both sides. How about here? See if you can complete the square on that. Tell me what I'm going to put here and here. You always start out by taking half of that middle number. Half of -6 is -3. Notice I put that -3 in parentheses because when I square it, I'll get a +9. You should always get a positive number in this step. So that +9 goes up here. Like that. So far, so good there. I'll take that as a yes. In fact, I'll be really helpful over here. I'll do the right-hand side for us. -24 plus 25 is going to be 1 for the right-hand side. Well, let's see what we get on the left-hand side. Now, in the first case, this is now a perfect square trinomial. It's, in other words, it's a trinomial that's the square of a binomial. So what do I square to get this? Sometimes people just put a 4, and unfortunately, that's not enough.
X plus 4.
X plus 4, excellent. So X plus 4, and over here, you know, I guess the way I like, or what I like about my little method of doing these things is that this number here gets used here. And likewise, that one gets used here. So this is going to be a -3 here. But I'm not just going to square a -3 to get this. I'm going to square what?
Y.
Y -3. Perfect. So as a little bonus here, what's the center and radius? Center would be
-4, 3.
-4 and 3. And the radius is the square root of 1, which is 1. Done. Nice. How's that one look for example C? You good on that one?
Good.
Now the practice here with completing the square is going to come in handy with the next problem, which is to put this one, this parabola. By the way, how do I know it's a parabola? How do I know it's not a circle or a hyperbola?
There's only one squared term.
Yeah, there's only one squared term, right? It's not going to be an ellipse or a circle or a hyperbola. There's only one squared term. It's going to be a parabola. Now, I'll show you two different ways to do it. I'll show you my way first, and then I'll show you the way that WebAssign might want you to do it. So my way is to look at this and say, you know what? This isn't a perfect square. So I'm going to start by moving the 5 to the other side. And when something changes sides, what else changes?
Signs.
Signs. So we get y plus 5 equals x squared plus 4x. And now I want to complete the square on the right-hand side. So, okay. That's going to be 1/2 of 4, which is 2. And then 2 squared is 4. So that's kind of some like little side work here for us here. So 4 is the number that completes the square here. So let's put that in. This is x squared plus 4x plus 4. If I put a 4 there, I've got to put a 4 here. Both of these sides can be simplified. 4 plus 5 gives me 9. And the right-hand side is now a perfect square. What do I square to get the right-hand side?
X plus 2.
Excellent. X plus 2 squared. There's one last thing that I need to do, And that's, I need to get y by itself, so I'll move the y to the 9 to the other side. When I put it on the right-hand side, what happens to that 9?
It turns into a -9.
Awesome, thank you, Courtney. Turns into a -9. And that's your equation. Great. WebAssign has a little different take on that. I'm most comfortable moving the 5 to the other side. They might ask you to do something like this. Before I show you WebAssign's approach, are we okay with this one? Hopefully just a little practice with parabolas and completing the square. By the way, it's not too soon to do some review. Your test is a week and a half away. Your final exam, that is. This is a basic graph that you should know the shape of. This one's been shifted from that basic shape. How has it been shifted? What does a +2 in the squared part do?
Left 2.
Left by 2. And then what? What else?
Down by 9.
Down by 9. Awesome. Down 9. In fact, that's its vertex. Is -2, -9 is the vertex. And it's great once you have it in this form, you can just read that information right off the page. If you have to follow along with WebAssign's game, it would look like this. So I'm going to rewrite the problem. They're just going to keep this 5 on the right-hand side. So what they'll do is write this as x squared plus 4x plus something minus 5. And so you got to look and say, all right, well, what number is it that completes the square here? And it's the same work that we did up above. The number that completes the square here is 4. But I can't just add 4 to the right-hand side. I've got to keep it in balance. So if I add 4 here to keep it in balance, I'll subtract 4 here. That's the way they're going to do it. And then both of these are going to simplify. That'll simplify, and this will simplify. That latter part turns into a -9. And then this part turns into your x plus 2 squared. All right. And I didn't show the completing the square part here, but we did that up above. You know, whatever. You got to be careful that you're subtracting this number here to balance it out there. It's a different approach. It works, but you're free to do whatever you want unless the problem is actually working you through it this way. All right, so let's look at ellipses. The first one is a reminder as to why we actually take the time to plot the vertices, because plotting other points, like any other point, becomes a real pain. Let me show you. Now, I've changed things up in this problem to ask you to substitute in x = 3 and find values for y. So we'll do it that way. Here's your ellipse. Let x = 3. So if I let x = 3, that becomes 3 squared, or I've got 9/16 plus y squared over 4 equals 1. Okay. Well, it's kind of messy to solve for y. And my suggestion to you would be this. Let's multiply both sides by 16. That's the lowest common denominator. And when I multiply everything by 16, then I should get rid of all my denominators. I won't have any fractions left. So 16 times 9 over 16. In fact, if it makes you more comfortable, you can think of it as 16 over 1. 16 times 9 over 16, those are going to cancel. I'll get 9. 16 times this, the 4s will cancel, leaves me with 4y squared. And 16 times the right-hand side gives me 16. So that's a little bit more user-friendly. Subtracts 9 from both sides. Divide both sides by 4. And the most important part is to take plus or minus the square root on both sides, or on the right-hand side, square root of 7 over 4. Not necessarily a very pretty number. I wouldn't want to have to graph that. It'd be kind of a pain. Yeah, it wouldn't be kind of a pain, it would be a pain. You could, but yeah. The better thing to do is to plot the vertices and work it that way. So, any comments or thoughts on this one? You know, a nice little reminder here on solving quadratic equations. This one we used the square root property. That worked out pretty nice. You couldn't factor this one to solve it, so why not use the square root property? It's better than the quadratic formula in this case. Let's go down to this equation down here, x squared plus y squared, or excuse me, x squared over 49 plus y squared over 36 equals 1. I don't know if you heard my little doggy moaning. That was the background noise there. They made themselves comfortable down here in my basement. So, let's see. There's probably one thing I would do to this equation, and that is x squared over 7 squared plus y squared over 6 squared equals 1. Now, why make that adjustment?
It's the standard form.
Yeah, it's the standard form. Perfect, perfect. And with the standard form, it makes it easier to graph. Now the center on this one is 0, 0. And what you're going to do in graphing this is move this distance away from the center in the x direction. So -7 to the left, 7 to the right. So moving a distance of 7 away from the center in either direction, and then up 6 and down 6. So -6 and +6. And those 4 points are your vertices. And then it's just a matter of playing connect the dots. And I missed it there. There. And there's your ellipse. Understanding this will allow us to kind of reverse engineer our next one. But are we okay with this one? So let's reverse engineer the next one. This next one, they give you the graph. And what you're going to have to do with the graph is basically count how far away from the center your vertices are in each direction. Overall, you know what the shape of this is going to be in terms of its equation. It has to be something of this form. X squared over something plus y squared over something equals 1. It's just a matter of determining what are these somethings. They're both going to be things that are squared. How far away are you moving to the right to find vertices in the x direction? There's this blue distance here. In other words, what number am I going to write underneath my x squared term?
3.
3. So that'll be 3 squared. Excellent. And in the y direction, you have to count a little bit. What am I going to put underneath the y squared term?
5.
5, yeah, put a 5. So there's your answer right there. You could also write it as 9 and 25 as you input it into WebAssign. That'll take both of them. And let's do one last one for ellipses. This time we're going to start with an ellipse with a center other than 0, 0. So it's going to be the one that you see here. X minus 8 squared over 49 plus y minus 1 squared over 16 equals 1. Zoom. There we go. That's a 9. I'd probably do this. I'd probably write it as x minus 8 squared over 7 squared plus y minus 1 squared over 4 squared equals 1. What's one important difference between this one and the last one? Can anyone see? Is the center 0, 0 anymore?
Nope.
No.
No. What makes the square term here equal to 0? What value for x?
8.
8. Excellent. Thank you. And Robert, keep going. What makes the y term equal to 0?
1.
1. There's your center, 8 and 1. Let me see if I can't approximate a graph on this. And let's just do units of maybe 4 in the denominator, or 4. So 4, 8, 12, and 16. So my center is at 8 and 1. So that's right here. It's not really a point on the graph, but I'm just going to put it there just to help guide myself. In the x direction, I've got to move a distance of 7 to the right and 7 to the left. So that's going to put me a little bit to the left of 16, out here at 15, and a little bit to the right of 0, out here at 1. So there's 2 points in that direction. How far do I have to move to find the vertices in the y direction?
1.
Yeah, up 4 and down 4. So 1, 2, 3, 4. So down here and up here. So those are the 4 points of your ellipse. If you wanted, you could figure out the coordinates here. That'd be 15 and 1. That'd be 1 and 1. Up 4 here from center, you're going to be shifting that. You're going to add 4, so it's going to be 8 and 5. And then down 4, subtract 4 from that would be 8 and negative 3. I don't know as though you're going to need to find the actual coordinates, but there they are nonetheless. And let's see if I can't make it this time. Yay. That one wasn't too bad. Usually what I do in class is I walk around and I look at other people's ellipses, and then I feel better about mine. All right, I'm kidding, sort of. All right. Okay with ellipses?
Yep.
Awesome. Onwards to hyperbolas. Now, I actually wouldn't need to change this equation much to make it a hyperbola. What one change could I make to make this graph a hyperbola?
Change the plus to a minus.
Perfect. Change the plus to a minus. And that's something that's, you know, a small detail, but it makes all the difference in the world. So when you have two squared terms in your graph, one of them is positive and one of them is negative, then you're looking at a hyperbola. So let's take a look at some hyperbolas, finish this section up. So here's your equation, x squared over 9 minus y squared over 49 equals 1. If you're clever, you can eliminate two choices right away. If you wanted to improve your chances of guessing correct, which two choices could I eliminate right away? From A, B, C, and D.
Is it B and D?
Excellent. It's B and D. Somebody tell me why Robert thinks B and D, and he's correct. Why can we eliminate B and D?
Because it's opening the wrong way.
Yeah, B and D open up and down. And we know because x squared, the positive term, comes first, then this has to open left and right. Left and right. Now, to further narrow it down, you might want to think of it as x squared over 3 squared minus y squared over 7 squared equals 1. The vertices are going to be in the x direction. They're going to be a distance of about 3 away from the center. The center in this case is 0, 0. So which one of these looks like it has vertices that are a distance of about 3 away from the center, either A or C?
A.
Which one do you think?
A.
Yeah, I'm thinking A. I mean, this one, I mean, even without getting too close to the scale, I mean, that number is closer to 10 than it should be if you're representing a 3. So here you go. -3 and 3. Those are your vertices on the x-axis. So the correct answer is A. Let's do a little bit more work with hyperbolas. So when you graph hyperbolas, at least the way I teach it in class, is we draw this box here. And this box allows you to draw the diagonals, which are asymptotes to the graph. So these red lines or kind of purplish pink lines extend out in either direction and get closer and closer to this blue diagonal line. I'm going to highlight that blue diagonal line in yellow. But your graph here is going to get closer to the asymptotes in either direction. So drawing that box does a couple things. First of all, it gives you the asymptotes for the graph. And secondly, it helps you draw a reasonable graph without really plotting a lot of points. There's only 2 points that you're going to graph. And those 2 points are right here and right here. Those are the ones that have to be really accurate. Those are your vertices. So these distances, though, in the x direction, what I have labeled green here, and in the y direction, what I have labeled blue, those distances represent what's going to go in your denominator. First things first with this one. Is it going to be an x squared term first or a y squared term? Which one's going to be the positive term in this? So in other words, should it be something like this, x squared over a squared minus y squared over b squared, or y squared over a squared minus x squared over b squared? First one or the second one? I think somebody started to say it and I stepped on them.
First one.
First one, because this one has to open left and right. Both of these have a center at 0 and 0, but this one opens left and right. So now it's a matter of determining A and B. Let's see if we can't do that. A is going to be how many steps you take to get to the vertex in the X direction. 1, 2, 3, 4, 5. So it's going to give me an X squared over 5 squared. Can someone tell me what I'm going to put underneath the Y? How far is it that I have to move to get to this value of Y?
Is it
No one's-
7?
Yeah, it'd be a 7. Thank you. So X squared over 5 squared minus Y squared over 7 squared. And that's it. Yay. Kind of over time a little bit, so I'm going to kind of cut things short a little. But in terms of graphing things, one big difference between this one and the previous one is that the center is at -3 and 4, and then you're going to start drawing your box from there. Let's finish it up with some look at some conic sections. In other words, which conic section am I? And we'll start with A here. What kind of equation or what kind of graph am I going to see when I graph equation A? X equals Y squared minus 2Y plus 11.
Parabola.
A parabola. Good. So let's put that in green. Match parabola. Let's move down to the next one. X squared over 9 plus Y squared over 64 equals 1. Well, it's not going to be a parabola anymore because you've got 2 squared terms. So what is it going to be then? Well,
An
if you got, go ahead.
An
An
ellipse.
ellipse.
An ellipse. Excellent. So that one's going to be an ellipse. I'll put that one in a matching blue here. Now down to C, equation C, what I guess I would draw your attention to is that the number in front of each of these squared terms is the same. Let me see if I can't make that a little bit more pronounced. So there's like a 1 here and a 1 here. The thing to see is that both of these are the same, as opposed to down here where those numbers are different. And that implies that you're going to get different equations. So the first one is going to be what type of equation when you graph it? First one's going to be a circle. If the coefficient of those square terms are both positive and the same, in this case both 1, then it's going to be a circle. If the equations are both positive with different coefficients, then it's going to be an ellipse. And we didn't cover it in these examples, but if I change this plus to a minus, like I did here, now what kind of a graph am I looking at?
Hyperbola.
Yeah, that'd be a hyperbola. Awesome, thank you. Whew. All right, that does it here. Any comments or thoughts on your little whirlwind review? Okay, let me stop things and then.
Yeah, I do.
Yeah, go ahead, Portia. Question?
Is this actually the final or just the fourth exam?
It's just the next exam. So the final is going to have a
Do
few
you hear
more
me?
things on it. It's going to be the fourth exam, and that'll be Monday.